Hello students, in this video we're going to attempt to answer the question, how do we know if an inverse function exists? Okay, so in order for us to answer this question, we have to first understand what exactly is a function, and in order for us to understand what is a function, well, we have to first understand what's a relation. Okay, so let's try to answer that question first. Okay, what exactly is a relation? Well, a relation is not quite a function, but it's something a little more general. It's just a set of ordered pairs, or in other words, it's a set of inputs and outputs, right? So it's a set of data points. So for instance, if you were to collect data on the amount of calories you're intaking, right, and then you pair that with the weight, okay, that you measure from day to day. Okay, so calorie intake, comma, weight. Okay, and you do this for maybe 15 days, 30 days, just to keep track of the calorie versus the your weight gain or decline. That right there is a relation. Okay, so an example of this when graphed, may look something like this, right? So if you have a certain number of calories taken per day, and then you're going to have certain, well, your weight is not going to fluctuate as much, but if you have really large intake of calories, perhaps your weight will go up. Okay, so hence we have this kind of relationship. Okay. Of course, relations don't always have to look like this, okay? You can have maybe on some odd days, okay, where you take in, where you have some amount of calorie taken in, right? But then because of your metabolism or whatever, okay, then you may gain weight, or maybe perhaps you may lose weight, okay? So depending upon what the circumstances are, okay, the relationship may look a little different, okay? Because it's not as simple as just taking in calories and then just measuring weight. Your bodily function has a lot to do with it, the biology of it all. Okay, so we can certainly talk about relations in this manner as points, okay, or as I put it in the definition there, as ordered pairs. But we can also talk about relations as not ordered pairs, but as a set of points that are connected, that are drawn. Okay, this is an ellipse. Okay, this can certainly be a relation. All the different points, all the x and y coordinates that are on the ellipse, okay, they form a relation. This over here, which we are so familiar with, okay, at this point, this is another example of relations, parabola, okay. All the x and y coordinates on the parabola can be accounted for, and they can be accounted for in a collection of ordered pairs. Okay, so an ordered pair, again, one more time, is a set of input and output. So whatever x we throw into the quadratic equation, we can have a y coordinate to pair with that. Okay, so that's a relation. Okay, so what's a function then? Well, a function is actually, it's also a relation, okay, but it's a relation that passes the vertical line test, or in other words, every x coordinate, every input has only one output. So how does that look like? Well, as it turns out then, if we base a definition of function on the vertical line test, or that one input has only one output, then this ellipse in the previous drawing from before, this would fail, right? So this is not a function. Whoops. So this is not a function. Let's take a look at the next example, right? Is this a function? So one input has one output. So yes, this is in fact a function. So again, here we only have one output. Here, for one input, we have two outputs. Let's take a look at the next one. Is this a function? Absolutely. This is indeed a function. Again, we only have one output. What about this guy? Right? So, can a set of ordered pairs like this be considered a function? Well, in this case, actually, this is actually not going to be a function. It's not going to be a function not because the points are not connected. It's because it failed the vertical line test, or in other words, for one of these inputs, okay, for one x coordinate, we have multiple y coordinates, and that's not good. Okay, so this is not a function. What about the next guy? Let's see here. Is this a function? This indeed is a function because, again, it passes that vertical line test. What about the next one? Well, actually, the next one is not. It's a summary. So, as it turns out, all functions are relations. However, not all relations are functions. Don't forget our goal for this video, right? We're trying to answer this question. How do I know if an inverse function exists? So we're getting there, I promise, okay? So now we've established that all functions are relations, but not all relations are functions. Okay, so does every function have an inverse function then? That's what we're getting closer to answering that original question now, right? So say, for instance, okay, I take a function, and the function looks like this parabola here, okay? And knowing what I know about inverse, right? Knowing what I know about the inverse is simply the reflection of the original over the line y equals x. Now, is this going to be an inverse function? Well, as it turns out, this is not an inverse function, but it's certainly an inverse relation, right? No, it's not an inverse function because f inverse is not a function, right? This fails the vertical line test. We have one input with multiple outputs. So no, this is not a function. However, it is the inverse, okay? It is an inverse relation, okay? I'll give you that. Okay? So it is important to understand that every function will have an inverse relation. We still haven't answered the original question. How do we know if an inverse function exists then? Because that was our original question, right? One more time, getting back to the original question here. How do I know if an inverse function exists? Well, we now are getting closer, right? We now figured out that every function will have an inverse relation. Well, how can we tell if an inverse function actually exists then? So let's say we draw another random function here, and we reflect this over the line y equals x. So I want to try to the best of my ability to draw this, okay, as a reflection. So it will look something like this. That's the best of my abilities, okay? Something like that. Maybe this a little more curved this way. Yeah. Something like this. Okay? So is that going to be an inverse function? Of course you'd say no. But what's the pattern then, right? There's no inverse function there. What about this guy? So again, I'm going to try the best of my ability to draw this. So this is, again, the reflection would look something to this effect, right? Will an inverse function exist here? It certainly looks that way, right? So this is yes, of course. Try to come up with a pattern of how we can identify whether or not an inverse function actually exists. Let's take a look at the last scenario. Whoa, this looks a little different, right? How do we know if an inverse function actually exists? Again, I'm going to try my best abilities here to draw this. So it's going to look something like this. Whoops. Right? Okay. So is this the inverse function? Right? Is that a function? And you would say yes again. So hopefully by now, okay, having gone through this, what is the general conclusion that you can make? Well, if the vertical line test is the test to see whether or not a relation is a function, then to see whether or not a function will have a relation, we need to perform both the vertical and horizontal line test. So if a function were to pass the vertical and horizontal line test, what this would imply then, right? If we reflect the function over the line y equals x, it will most certainly pass the vertical line test for the inverse. In mathematics, we describe this kind of situation where a function passes both the vertical and horizontal line test. We describe that as being one-to-one. And what does it mean for something to be one-to-one? Well, what that means is, okay, is every x on this graph has its own unique y. The y coordinates will never, ever repeat itself. Y coordinates will never repeat itself. Unlike this example over here, right, where the y coordinate repeated itself several times, right? It repeated itself 3 times. Just like over here, you're going to have for every one for that one x coordinate, we're going to have 3 y coordinates. So a function that is described as one-to-one, or a function that passes both the vertical and horizontal line test, okay? If a function is one-to-one, what that would imply is the inverse function will exist. So again, if a function were to be classified as one-to-one, then the function will have an inverse function.